We have a couple different types of equations to look at today in section 6.5, and this is our last little bit of new content before we start getting ready for our test. The types of equations that we look at today are different because, like an example for A here, I don't just have a variable underneath the radical. So my example here, I have the square root of 5x minus 1 plus 3 equals x. I don't just have my variable underneath the radical, I have a variable on the other side or somewhere else in my equation as well. Similar idea as before. I need to get rid of that square root first by getting the square root by itself and then squaring both sides. So in this case, I have to subtract 3. Then after that, the thing that is most important to remember and the most common mistake to make is that when I square both sides, we have to square both sides of the equation, not just the individual terms. So x minus 3 squared, remember that means x minus 3 times x minus 3, which is x squared minus 6x plus 9. This is really going to give us a quadratic equation to solve. And then our square root of 5x minus 1 squared is 5x minus 1. I have my quadratic equation here. Let's move everything to one side, make our equation equal 0. So I'm going to subtract 5x and also add 1. 0 equals x squared minus 11x plus 10. Then this equation, we could solve a couple different ways, any of those strategies that we've used in the past to solve quadratics, but don't forget about factoring. Most of the time, I'd probably say 95% of the time, you'll be able to factor what you have here. X squared minus 11x plus 10, that factors is x minus 10, x minus 1. Then we make each part equal 0. So x minus 10 equals 0 when x is 10. X minus 1 equals 0 when x is 1. The other thing we have to check, since we at some point squared our x, we squared our variable, we have to check for extraneous solutions. If you remember way back to chapter 1 when we solved our absolute value equations, we checked for extraneous solutions then. And that just means a solution that it looks like it works, but it doesn't really work. And in this case, that comes from squaring our variable. So if x is negative, squaring our variable would make it positive, and going from there. So take each value that we found, plug it back into your original and see if it works. Then have the square root of 5 times 10 is 50 minus 1, and then plus 3. This should equal 10 if we're right, if this is actually a solution. The square root of 50 minus 1 is the square root of 49. 7 plus 3, that equals 10, that works. So x equals 10 is for sure a solution. Let's check the x equals 1. Plug it in. Square root of 5 times 1 minus 1 plus 3 should in theory equal 1. Now the square root of 4 minus 1, oh sorry, it should be 5. 5 times 1 minus 1. The square root of 4 is 2 plus 3. That doesn't equal 1. So x equals 1 in this case is an extraneous solution. X equals 10 is my only actual solution.